The expansion of renewable energy adoption and the development and expansion of data centers of generative AI are progressing. Energy storage systems responsible for stable power supply require larger capacity and higher output batteries. Consequently, the shift from traditional lead-acid batteries to smaller, lighter, and higher energy density lithium-ion batteries is accelerating. However, lithium-ion batteries are more expensive than lead-acid batteries and require systems to prevent fires, leading to increased manufacturing costs. To address this challenge, we have developed a 48-volt BMIC for industrial equipment, equipped with fault diagnosis and fail-safe functions, leveraging our automotive battery control technology cultivated over many years. This product achieves both enhanced battery system safety and reduced system cost for lithium-ion battery-equipped storage systems. Let's explore the 3 key features of this product. Feature 1. Improvement of system safety and cost reduction. The major internal circuits of this product are equipped with diagnostic functions and fail-safe functions. This diagnostic function can detect main circuit failures and control the cutoff switch, achieving both enhanced BMS safety and reduced system cost. Feature 2. Efficient utilization of battery capacity. This product has achieved voltage measurement accuracy of plus or minus 2.9 millivolt. By reducing voltage measurement error, maximum battery capacity can be used. Feature 3. Long battery life. By achieving an operating current of 260 microamperes, which is 10% lower than that of products from other companies, and optimizing the circuit design to reduce shutdown current consumption to 0.1 microamperes or less, we enable long-distance transportation and long-term storage of battery packs. Finally, let me introduce the specifications of this product. We offer a product lineup that meets customer needs by aligning with the control methods of battery cutoff circuits.